Yo, Buckley's back, and we got ourselves another motion time graph. This one's for Jasper again. They asked in one of our previous videos if we could produce some more motion time graphs, and we delivered. Please leave more comments asking for particular topics, and I'll provide the solutions for you. This time we're looking at AQA, and it's a multiple choice, and we're looking at the variation of acceleration versus time. Pretty uncommon, actually. But let's have a little look at what's going on. Once I've identified what I've got to look for, I'm going to go up and identify some key markers or key principles inside the question. This time, an object is thrown vertically upwards. So I know it's going directly up. It's not going to be kind of going off at an angle, and I haven't got to consider the trig. Once I've identified those key parts, I draw a picture, and it allows me to get my ideas out of my head onto a piece of paper, such as the velocity would be maximum the moment it leaves my hand. And obviously, all things must come back down to the ground. So my velocity at maximum height must be 0. So the velocity is decreasing. Super important when we're looking at the graphs. Speaking of maximum height, it tells me that maximum height occurs at capital T. I annotate on my graphs, another key skill I encourage you to do. Then it gives me this odd thing here, which is probably the distractor, that the terminal speed is reached, because I think they did that because that's got to tell students to look for a particular shaped graph that we often see with terminal speed. Not us though, we're not going to fall for those tricks. Next, I highlight that it's identifying that A is the magnitude of the acceleration, and then that G is the gravitational field or the acceleration due to G. Now that I've annotated my graph and I know that the ball is slowing down, I understand the situation, I can start looking at things and removing them as distractors. Because if I look at A and I think about what's going on, the acceleration of this object is increasing. Well, that can't happen if the ball's slowing down. So I can get rid of A, and when I look down, D is also wrong as well. I can get rid of D too. That leaves me with two graphs, B and C, and again, you can take the shortcut and you can just think about what is actually going on here. In C, the acceleration is still increasing. So that means actually my ball is still speeding up, which can't be the case. So we can straight away just rule out C and pick B. Hopefully you found that useful. And actually now you can start to approach these motion time graphs with way more confidence. And as I said at the start, please leave comments down below asking for particular questions or topics, and I'll provide the solutions for you. So until the next one, enjoy it and peace out.